Let's take a look at the proof. The limit of sine of x divided by x as x approaches 0 is equal to 1. Or it's the same thing if we do the limit of sine of theta divided by theta as theta approaches 0 is equal to 1. And to start this proof, we'll make the assumption that theta is positive and theta is between 0 and pi over 2. And then at the end, we'll deal with the case where theta is negative. And to start this proof, we'll start with the unit circle. So from the graph, we saw that the area of the triangle, and the large triangle here, QOB, is greater than the area of the sector, and the area of the sector is greater than the area of the small triangle, POB. And now let's take a look at the area of the triangle QOB. And so for triangle QOB, we notice that the height is QB and the base is OB. And then here we have the angle theta. And so the tangent of this angle will be the opposite divided by the adjacent. And so the opposite is length of QB and the adjacent side is length of OB. And notice that OB is 1 since we have a unit circle. And so we have length of QB divided by 1, which is just length of QB. And therefore tangent of theta, tangent of this angle, is going to be the length of QB, or QB is the same as tangent of theta. And the area of the triangle QOB is going to be 1/2 times the base times the height. And the base will be the length of OB, which is 1. And the height will be the length of QB, which is tangent of theta. And so we have area of triangle would be 1/2 times the base of 1 times the height, which is QB, which is also tangent of theta. And then all of this will be tangent of theta divided by 2. And so the area of the triangle QOB will be tangent of theta divided by 2. And now let's take a look at the area of the sector POB. And so this sector, the central angle is theta, and the radius is either length of OB or length of OP, which is 1. So length of OP is 1, length of OB is also 1. And remember that area of the sector is 1/2 times the square of the radius times the central angle. So in this case, the radius will be length of OB, which is 1. And then the central angle is just theta. And therefore, the area of the sector POB would be 1/2 times 1 square times theta. And so all of this will simplify to just theta divided by 2. And therefore, the area of the sector POB will be theta over 2. And then for the area of the small triangle, if we look at the triangle POB, the base will be OB, the height will be PR. And then also notice that the triangle POB, inside of it, we have the right triangle POI. r. And therefore the sine of this angle, sine of theta, will be the opposite side, which is PR, divided by the hypotenuse, which is OP. So the sine of theta will be length of PR divided by length of OP. But length of OP is just 1. And so we have length of PR divided by 1, which is length of PR. And so sine of this angle is the same as length of PR. And the area of this triangle POB, it'd be 1/2 times the base times the height. The base is just 1. The height is PR. But length of PR is the same as sine of theta. And so area of the triangle POB be 1/2 times 1 times sine of theta. And so simplify to sine of theta divided by 2. And so in summary, the area of the large triangle is tangent of theta divided by 2. The area of the sector is theta divided by 2. The area of the small triangle is sine of theta divided by 2. And now we'll simplify this inequality. So first, let's multiply each term by 2. So multiply everything by 2, and we'll end up with tangent of theta, theta, and sine of theta. And then next, divide each term by sine of theta. So divide by sine of theta, divide by sine of theta, divide by sine of theta. Tangent of theta divided by sine of theta will be sine of theta over cosine of theta divided by sine of theta. And then simplify to 1 over cosine of theta. So for this part, we have 1 over cosine of theta, and then sine of theta divided by sine of theta is just 1. And then next, we'll take the reciprocals and reverse the inequality signs. So turn everything upside down, or take the reciprocal. So this will become cosine of theta over 1. This will be sine of theta divided by theta, and then the reciprocal of 1 is just 1. So right here we have cosine of theta, and then right here we have 1. And so now the quantity sine of theta over theta is between cosine of theta and 1. And then we'll take the limit of each term and let theta approach 0. So as theta approaches 0, the cosine of theta will approach 1. And therefore the limit of cosine of theta as theta approaches 0 is 1. And then the limit of the constant 1 is just 1. As though we have this limit quantity is trapped between 1 and 1. And by the sandwich theorem, if we have a limit quantity trapped between 1 and 1, the limit of the quantity, this limit quantity is equal to 1. And then for the case where theta is negative, or theta is between negative pi over 2 and 0, recall that cosine of theta is an even function, meaning that cosine of negative is the same as cosine of theta. And then sine of theta is an odd function, meaning sine of negative theta is the same as negative sine of theta. And then for this quantity right here, sine of negative theta divided by negative theta, it would be negative sine of theta divided by negative theta, or just sine of theta divided by theta. And therefore this inequality right here is valid when theta is positive or theta is negative. And that's the end of the proof.